Okay, folks, so today we're taking a look at fractional exponents. So can someone please, in their own words, tell me what the product rule is? There you go. Ladies and gentlemen, what is the product rule? Brandon. Yes, when you have like bases, you add the exponents. So here we have a, we get n plus x. So take a look at our first example. You have x to the 1/2 times x to the 2/3. So what you want to do with those fractions is you want to add them. You want to add them. So my advice to you is that when you're dealing with fractions, what you want to do is you want to do your fraction work off to the side. You want to do your fraction work off to the side. So over here, you get 1/2 plus 2/3. The reason I'm doing it off to the side is because a lot of students I've noticed try and do the work here. They try and, multiply this by 3 and multiply this by 2, and it gets really gross looking on their papers, and they can't see what they're doing. Instead, I'm going to come over here and multiply this by 3, multiply this by 3, multiply this by 2, and 2. So I get 3, 6, plus 4, 6. So I get x to be 7, 6. So once again, the rules have not changed. All that's changed is instead we just have fractions that we're adding. So we just have to take an extra moment to think about it. So go ahead and take a moment and take a look at this second problem that I'd like you and your partner to do. Y to the 2/7 times y to the 1/4. Go ahead and simplify that. Once again, you're just adding fractions. All right, let's go back to learning. So, when you added these two together, you have y to the 2/7 and y to the 1/4. So when you add these, once again, my advice, do your adding off to the side. All right, that way it doesn't get all jumbled up. You have 2/7 plus 1/4. The common denominator is going to be what? Minus 28. Multiply this side by 4. Multiply this side by 7. You get 8/28 plus 7/28. You get y. Thank you, Miles. To the 15/28. Once again, nothing has changed. It's the exact same rule. It's just some fractions. Does anyone need any more time on this? Okay. Take a look at our next one. The quotient rule. Can someone in their own words describe the quotient rule to me, please? In your own words? Yes. Exactly right. When you're dividing like bases, you subtract the exponent, and then where do you put the remainder? You put it on top or on bottom? It always goes on top. It always goes on top. So, take a look at this. Once again, I'm going to do my fraction work over here. Some of you may be like, why do I have to do this? I can do it in my head. And if that's you, you should feel awesome in that. If it's not you, you should feel awesome. You get 9/12 minus 4/12. So you get y to the positive 5/12. Oh, nice. Just really confuse everybody and just throw new bases on. Yeah, just get it. Go ahead and try that one. So first off, before you jump into it, take a look at it. You have 2/3 on top and 3/5 on bottom. Which of those fractions is bigger? Which is bigger, 2/3 or 3/5? 2/3 is bigger, which means you should end up with a positive fraction. That's a way to know you did it right. When you subtract, it should be positive. All right, so go ahead. I'll give you a minute. I'll time you so you know how you did it. Who's that? No, you always put the fraction up on top. Spend 30 seconds. What's up? Do you have a question, Robbie? No. Okay, I thought you said something. We'll talk about that next week. That was 52 seconds if you're trying to be on time. Could someone please walk me through what you did? Someone please walk me through, because even once I walk through what you did. Okay? Still exactly as you go. Right? Questions on the quotient rule? Power of a power. Could someone please describe what you do in this case? You have a power to a power. What are you going to do? There's going to be a power to a power. You're going to multiply what? The exponent. You're going to multiply this times this. So I get 1/2 times 3/4. Then what's the difference between multiplying fractions and adding subtracting fractions? Multiplying, add, and wait. No, you multiply, you go cross. Very good. You go straight across. We don't need common denominators. So in this case, I get x to the 3, x to the 3. All right. I think you should be able to do this question in about 30 seconds. Go ahead and go. You have y to the 2/3 to the 7/5. Y to the 2/3 to the 7/5. That's 30 seconds. What'd you get? Oh, you just want to answer so badly. What'd you get?
I got
Y. Brayden, what'd you get? I think we'll go with that. Two people. Questions on the power of the power? Oh yeah. Anytime you're multiplying fractions, it's easy. Okay. Just like last time, the negative power property, this is what we're going to learn our new thing. Alright? Could someone describe to me the negative power property? What do you do when you have a negative exponent? What do you do when you have a negative exponent? Any, what was that? Okay. Miles. That's the worst explanation I've ever heard. Kayla, a little more specific? Okay. Oh. And if it was in the denominator, what would you do with it?
If you split it, then it's not negative.
Ray, do you want to elaborate on that? No! Hold on, wait, hold on. Just so everybody knows, those people listening at home, yes, that was the correct answer. I just wanted Ray to also elaborate. That's a much shorter way to do it. I said hop the line and switch the sign with the 6 little words I told you, right? I know. That's why I wanted the specific. And then just so everyone knows, at home, Kayla was right.
Thank you.
Kayla was right. All right. So in this case, I get 1 over A to the 3/4. So here's where this is where our new thing comes in, our new piece of learning, because fractions are new. So you're not allowed to have fractional exponents in the denominator. You're not allowed to have fractional exponents in the denominator. No, you can't switch it to 0.75 either. So we need to get rid of it. Did you have a thought? What's the thought? Okay, but so think about what happens when you have exponents and you're multiplying them. So if I multiply this by a to the something, what's going to happen with the 3/4 and this exponent? Robbie, what was that? Oh, no, you said something. What's going to happen with whatever exponent is right here? Miles, what's going to happen with whatever exponent I put right here? Right? You'll add it. Right. So hold on. No, don't let me lose it, ladies. So whatever exponent I put right here is going to get added to this exponent. Because that's how the product property works, right? Whenever you have like bases being multiplied, you add. So in this case, what would give me a whole number in the denominator? I have 3/4. What would give me a whole number in the denominator? Robbie, what was that? 4 over 3 when you add them? No, that would not. That's if you were multiplying, but you're adding. Robbie, what did you add to 3/4 to get to what? 1/4. You're going to multiply the top and the bottom by 1/4. Yes. You're allowed to have a fractional exponent in the numerator, just not in the denominator. That is your answer. It could be, but I want to make sure everyone sees that it's a 1 because 3/4 plus 1/4 is 1. That was a conscious decision of my part. You do not need the 1. Brayden? Because what we're going to learn next week is that a fractional exponent is another way to write a radical. So a to the 1/3 is actually the cubed root of a. You can't have a radical in the denominator. You can't have a fractional exponent. And we're going to talk about that next week. What? Or next week? No, that's a factorial. Yes. Because they're being multiplied, you add the exponent. Adrian? You in the green shirt? What's up? Okay. Right. 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 I know keeping that straight is tough. Yes, sir. When you're multiplying like bases, what do you do with the exponent? You add. So yes, I'm multiplying, but I add exponents when I'm multiplying. But I know that's tough. That's why we spent 5 days on exponents. All right, take a look at this example. Much easier. You have 1 over b to the negative 5/7. 1 over b to the negative 5/7. So just think about it. Let's not shout anything out yet. You have an answer? You know what to do with the negative exponent? Okay. Someone like to volunteer? Looking for volunteers for this? Make your life easier. It's a negative. So what, James, what can you do? Yeah, just bring the whole thing to the top. You're done. Problem done. Boom. Because it's a negative exponent. So just life easy. It's done. Yeah. Don't make your life hard. It's easy. It's easy to find.
And that's what happens.
Correct. Exactly. All right, let's move on. The power to a quotient. Power to a quotient. In your own words, can someone describe to me what you're going to do here? In your own words, can someone describe to me what you're going to do? Wow. Cool. So I get 2 over 1 times 1 over 3. That equals 2/3. So on top, I have x to the 3rd. On bottom, in blue, I have 3/2 times 1/3. So I get y to 1/2. Now, looking at this, what am I not allowed to have in that problem? Zero. What am I not allowed to have? A fraction in the denominator. So right now in the denominator, I have y to the 1/2. I need to get to the next closest whole number. Catherine? That's a 3. So I have y to the 1/2. So I have half of something. I need to get to the next whole number, which would be 1. So Megan, what do you add to 1/2 to get to 1? You add a half. We're just going to multiply the top and bottom by y to 1/2. So in red, on top, x to the 2/3, y to 1/2. On bottom, y or y to the 1st. Miles, what's up? Can't have a fraction on the bottom, and what we're going to learn next week is that a fraction on the bottom is another way of writing a radical expression. So for instance, x to the 1/2 is the same as the square root of x. And you're not allowed to have radicals in the denominator, so you can have fractional exponents. That's which y? Right here? Because what is 1/2 times 1/2? You add the exponents, you get 1. So that's why I keep it, because it's still there. You and your partner, let's try this one. Let's do 2 minutes. Cover it up. This problem says 3 over x to the 3/7 all to the 4/3. Rationalizing the denominator on this one will be tricky. Please take your time. Yes, you should simplify always. Spend 50 seconds. Yes. Remember, chat with your partner, see how they're doing it. Ask them a question. They're there to help you. On bottom right here. What is 4/3? Yep. I think it's 6. Oh, no, 20 seconds. multiply the top to bottom line. With that. Whoa, sorry. You're multiplying it by something, which lets you add it. Right, so we're going to add the 4 7, you get 7. So you multiply the top and the bottom, like x. Oh no, that should still be 4/3. That should be 7. These are like things. Okay, wait, 3 7? Yeah. Yeah. Ladies and gentlemen, if I have your attention, please. Walking around, I saw lots of people distribute correctly and get 3. Now remember, it's not 3 times 4/3. It's 3 to the first to the 4/3. So this should be 3 to the 4/3. If you have 4, you multiply 3 times 4/3. On the bottom, you get x to the 4 7. So on top, I have 3 to the 4/3. On bottom, I have x to the 4 7. Medina, what's up? Let me talk about that next week. Okay? Let me talk about that next week. Lindsay? Because 3 over 7 times 4 over 3, cross cancel, it gives you 4 7. So now on bottom, I have 4 7. I'm not allowed to have a fraction. So I need to multiply it by x to the what? Honey, I'm going to multiply by x to the what? X to the 3 7. Why do I multiply by x to the 3 7? Why? Exactly right. You add the fractions, you get 1. On top, you get 3 to the 4/3, x to the 3 7. On bottom, you get x to the 1. Or just. Question? One more rule, I think an easy one for last. The power to a product. Can someone please describe this last one to me? Power to a product, what are you going to do? Rana, what are you going to do with that 1/2? What are you going to do? Distribute it to what? To the other exponent. Jens, what were you going to say? Distribute it to the other exponent. So once again, I'm going to bring my 1/3 times 1/2 up here. So I get 1/6. In blue, I have 3/5 times 1/2, which equals 3/10. So I get x 1/6. In blue, I get y. So I do this last one. And I have a couple example problems here. No, you messed up. This. Yes, you messed up too. Oh, I see a lot of people making a silly mistake. You messed up. Good. Oh. Yeah. Okay. That's what you people on the spot. But those of you who I walked by instead got it wrong, what did you do incorrectly? So one of you I said, Denise, what did you do? Right, there's a 1 on the 2, so it's 2 to the 4/5, x to the 15, y to the 4/30. Everything's being multiplied, buddy. So just because the 2 is connected to it, it is connected to it. But it still deserves to have the exponent distributed to the exponent that is on here. Right? So think about this. Think about this part right here. 2x to the 3rd. Does it equal 2x to the 3rd, or does it equal 8x to the 3rd? 8x to the 3rd. So the same rule applies here when you have a fractional exponent. All right. Why don't you pick 2 problems on this next page, and you and your partner can go ahead and do it. Pick 2 problems. We have harder ones and easier ones. This is not an Edmodo, this is just for you right now. I heard of one. Then we're going to talk. As you get started with your partner, a little more quietly for me. This evening on Edmodo, there are